So video number 10. This video is going to be about adding the Hall sensor input to my motor controller. This is the block diagram of the motor controller that I'm designing. And I'm just going to go to YouTube here and I'm going to add a title for this video. Done. So let's go to the schematic. The schematic is here, and we're going to start by adding a Hall sensor connector. I'm going to go to Mouser. I'm going to find some connector that I think would fit the requirement. For the Hall sensors, you typically have a 5-volt supply and 3 wires. So I'm going to go with 5-volt supply, and I'm going to have to level shift the 5 volts to 3.3 volts. And then I'm going to also check the data sheet for whether my circuit can be used with 3.3 volts. If there is any motor, I haven't seen any motor that uses 3.3 volts, it's usually 5 volts. But if for any reason some motor needs to have, or some motor has a 3.3 volts Hall sensor, then it's good to know if my drive is going to be able to support that motor. I think it should be fine. I think the threshold is very low, so I think it should be perfectly fine. Let's look at some connectors. I've looked at connectors before, but I haven't actually picked specific connectors, and I'm going to do that now. It's going to be a pluggable, pluggable terminal block. And it's going to have a small pitch, so maybe, let's see, maybe something like even 1.27, but there aren't many connectors that are 1.27, so it's better to pick something that is either 2.5 or 2.54. And it's actually even better if I go with 2.54, because that allows to just easily solder a small header if necessary. But in the design, I'm gonna pick a pluggable terminal, and it's going to be, let's see, it's going to be a through-hole package, although that removes all of the alternatives. So instead I'm going to just look at what we have here. So ideally something like this, but the price of this terminal block is prohibitively expensive, and there is not many of them in stock. So I'm going to look for something that is cheaper and more widely available. Let's just see what the cheapest one is. Oh, and I'm also going to pick the positions. So it's going to be 5-position terminal block. And then we're down to 29. And we have both plugs and headers. So this looks actually very good. This is a 2.54 pitch socket, and this would be, I think, the corresponding plug. This definitely looks like it could be the corresponding plug. Then we have also the double ones, which could be useful, although it's better if I do it's better if I use 2 different connectors, because this will be 2 different motors. I don't want to have both Hall sensors connected to the same connector. That would be bulky. So it is better to pick something like this. And most of them are not in stock, so I'll just filter them out. Actually, I think the first one here is a plug. Yes, it is. And then we have a plug that looks like this. This actually very much looks like a plug that is lockable. Let's see what this plug looks like. And there is not much information about this plug. So the thing I don't like about all of these connectors is that they are not, they don't have screw terminals. And I want to have screw terminals. I think screw terminals are easy to connect. You just cut the wires and you have a screwdriver, just remove the isolation from the wires and connect them to the screw terminals. And then you also have a plug because it will be both a connector and a plug. So it's very practical to use screw terminals. But unfortunately there are no screw terminals that have 2.54 millimeters separation between the pins. What I'm gonna do is actually I'm gonna have a look at some screw terminals that I have here. You're not gonna be able to see them because I don't have my webcam on right now, but I'm gonna try to find them anyway. There they are. So the screw terminals that I have here, I think they are 5 millimeters. I'm gonna check what the pitch on these screw terminals is. They are more like 3 something, so almost 4 millimeters. And they look pretty good size to me. I think anything that's smaller would mean that the screws will have to be smaller, which would actually be a problem. So I kind of understand why the screw terminals do not have 2.54 millimeters separation between the pins. So I'm going to remove that and I'm going to pick something that's a little bit bigger. So it could be 3.81 and it could actually be, let's pick both of them and see what we can find. Or actually, let's go to KiCad and see which footprints we have. Do we have any terminals that have that pitch? Because preferably I don't want to create a custom footprint unless I have to. So I'm gonna see which footprints I have. Terminal block. Let's see. No, come on. Just double clicked. I shouldn't double click. I should just browse. Okay. This is a block that looks like that. So all these, this is 3.5, and actually let's see. So ideally something like this. Horizontal, vertical. Yeah. So we have 3.5. We don't have the. We do have 381 there. That's nice. So this would be the 381. Okay. So there are a few footprints to choose from. So I think both would work. I'm gonna check out both. And now I think I can just I can search for plugs first. So let's search for plugs and have a screw terminal on the plug. And then I can search for the socket. Great. This is pretty much what I had in mind, but I don't like the price. I think they should be cheaper. Okay, there is definitely cheaper alternatives. They're still quite expensive though for a plug, but you could kind of guess because there are screws in this plug and it's quite a complicated design. So it's not just something that that can be just printed and that just has a few crimps inserted into it. So €2.5 is okay. And this would be, so the wires go in here, and then we can have a label there that says what each wire represents. So it's very nice. I think this is definitely the kind of plug that I will use. But the part that I'm going to be adding to my library now would be the other part of this connector. So it's going to be the socket. And let's see if we have any suggestions for the socket. So we have this socket. And this was a 3.5 millimeters, just to double check. Yes. Okay. And it looks like these two are pretty similar, but it could be that one is horizontal and one is vertical. So let's see. Or maybe one is upside down or something. Let's see. Maybe one is supposed to go on the underside of the PCB, and the other one is supposed to go on the top side of the PCB. So that the screws face in the upwards direction. What exactly is the difference between these two? Okay, so here we got the pins going right. Yeah, so it seems to be exactly, unless this one is actually a vertical plug. Unless that's the only thing about this plug. It certainly looks that way. Let's see. Through hole to vertical. Okay. So the one we're going to be using is this one. This one. And this is 3.5, 5 position, and it is a horizontal one. Yes, looking good. I'm gonna copy this, and they're quite cheap as well, €1. And then I will I'll close this footprint editor, and then I'll just add the Hall sensor connector. Let's see, do we have any connector we could reuse? So I have a few connectors already. I will just reuse one of them, or even better, just create a new part. This would be P con how. Okay, I'm gonna move this one out, and I'll add a few pins. More pins. C is 3, and then there is 5 volts. And I'll draw a small outline here. Great. And add a little bit of text here. It's going to be a 5-volt Hall sensor connected here. And the footprint, and I also need to add the article number. I think I have it, yeah. And then manufacturer number will not be visible, value will not be visible. Great. And then I'll add, let's just move the P reference. Then I'll add the footprint. So this would be 3.5. With 1, 2, 3, 4, 5. Yeah, cool. We can have the terminal block footprint assigned there. And now we can add the Hall sensor input here. Okay, I'll lower the voltage a little bit. So I will have, let's see if I have any 2 kilo ohm resistors here. Can open the, let's see, can open this with it. We have resistors that are, so far I just used 10K for the most part. Right, so maybe I'll use let's see. So the ratio of 0.66 and that would be, so if I use a 10K resistor at the top, I should have 6.6K resistor at the bottom. Although, is that correct? Let's see, is this really correct? 10, let's see, 16.6. this is bullshit, come on. I always find resistor dividers confusing. All right. So the calculation is going to be 5 times 10 divided by x plus 10k, and that would be equal 3.3. Okay. So move this out, we get 3.3x plus 33. So 50 minus 33, 50 minus 33, get 17, and then 17 divided by 3.3. Right, that's the resistance that I'm supposed to use. So something like 5k, so like 10k and 5k. That will be good for this level conversion. So I'm gonna add a few 10k resistors. And they will go up to the power rails. Or actually, let's see. No, we'll have them parallel, of course, to the signals. And VDD 5 volt is going to go in there. And then we have the ground. And then I'll find some 5k resistors. Let me just check something. Let's see. Okay. Let's go here and find some 5k resistors. So this didn't give very good results. So maybe I can just like passive components resistors. And I need a 5k resistor. Yeah, this looks good. Nice let's use this resistor. So I'm gonna add a 5K resistor. There we go. And I'll remove the supply field so that I get everything updated. Okay, so going to 5K. And then this will just go to the ground. Actually, I'm gonna move this there and I'll copy ground symbol. In previous versions of KiCad, the fields would actually be reset to their old position, so that's why I got into the habit of always leaving them where they are. So otherwise, when I would update the fields, I would get them all in their default positions again, and that was kind of annoying. But hopefully that is not going to happen. Let's see if it does. If I do edit, update field values. Great. So it doesn't move the fields. That's awesome. And then I'll just add the label here. So 3 labels. And this would be for the first motor. So how A1. Let's see. Copy that. How B1. And let's see. And how C1. And this would be how A2 and B2 and C2. Okay, great. Now there is something I want to double check, because since I messed up the calculation for the resistor bridge divider here, I may have done the same thing for a different bridge divider, such as this one. So let's just double check this. If we have 48 volts and then times 10 and then divided by 145. Right, okay, yeah. So this was correct. I didn't mess with this resistor divider. Great. Okay. So that's it for the, or actually it's not everything that I wanted to do for the HAL inputs. I have to protect them. So I haven't added any protection. I want to see if I can find any Schottky diodes in a package where I can have multiple of them, like maybe 3. I'm gonna go to the category for the Schottky diodes and I'll see if I can find something that has 3 diodes in the package. Dual, hex, octal, let's see. So what is, let's see. Triple. Awesome. Let's have a look at all of these triple diodes. BAT54. We have BAT54 in a triple package. Let's see what this looks like. So we have, basically we have 3 diodes like that. And this is good. I think for the HAL sensor inputs, it is sufficient to just tie them up to the I was thinking it would be sufficient to tie them up to the 3.3 volts, but I'm thinking also that since this is a cable, maybe I can find some triple ESD protection, just to make sure that we also have the ESD protection diode included. So if this was inside the circuit without any cables coming into this, then I would be using this diode, but I want to check if, let's see, so I'm not going to use that. I want to see if I can find some ESD protection. ESD and TVS. Three channel, good. And yeah, let's see what we get if we just pick 3 channels. So so what is this NUF? The NUF data sheet. What does this NUF looks like on the inside? Okay. This is for USB. Is there anything that is 3 channel? Was this 3 channel also? Interesting. Okay. This one's nice. Let's see what this looks like. this is pretty much what I need. This is good. So we'll just place it on the PCB by just running the traces underneath, pretty much. So is this SOT, is this normal SOT package or is this some special SOT package? 5-pin SOT package. Let's have a look at the packaging. PD SOT and 5. Okay, I'm gonna have to double check this just to make sure that the pin out is correct. This is definitely a part that I will add to my library. Okay, so I'm just gonna draw this symbol, and I'm gonna add a footprint if necessary for this symbol, and then I'll place it on this schematic so that the HAL ABC1 and ABC2 are connected to this ESD suppressor before going to the microcontroller. So I'll stop this video right now, and in the next video I'll just continue with the other parts of the schematic, but it'll be really boring to watch me create this symbol. I've created so many symbols already, so you pretty much know how to do that. Thanks for watching.